So I've got this rational function here. It's not factored or anything, but I graphed it. And what I'm seeing this line, and I see this line, and what is that equation, that line? Let's see. The scale's a little weird here. That's -1, -2, -3. The y-intercept, well, if that hole was filled in, right, if that hole was filled in, that hole would be at 0, 5. And so that tells me the y-intercept is 5. And I see a slope of up 1 over 1, up 1 over 1. Because remember, each of these lines are worth half. So I see the line 1x plus 5, except there's the hole at x equals 0. So let's go back and look at that function now, because what they're asking us to do is find out where the discontinuity is, and then what's the domain? Is that what they're asking us to do here? The zeros in the discontinuity. So what we do is, the way when we start dealing with these rational functions now, and they'll get more complicated later on, but right now it's great that they're throwing just finding the holes in the graph at you. And so what we're going to do is we're going to factor everything. So what I see, I'm going to ignore, for momentarily, I'm going to ignore the x in the denominator, and I'm just going to zoom in and look at x squared plus 5, plus 5x. And I see a greatest common factor of x. So I can divide both of those by x, or undistribute it, right? And then that's over x. And then because there's this common factor in the top and the bottom, you would like to factor it out. I mean, would we like to cancel it to make it a little easier? And we certainly could, as long as we promise we don't actually forget about it. So once I take care of that problem, what I see is y equals x plus 5. And notice that's exactly what I saw when I graphed it, the line y equals x plus 5, except when at x equals 0, there's a hole in the graph. And you see how, so how can I come up with that without having to graph it? Well, you take a look at the top and the bottom of a rational function, and you always ask yourself, well, the discontinuity is always going to happen where the denominator equals 0. Here, let me change this to a different ink. When the denominator is equal to 0, that's where it's going to happen. And since that's just x equals 0, we know that's the problem. So, the other thing we want to pay attention to is that the same factors in the numerator and the denominator, because that doesn't always happen. It still gets a discontinuity in there, but something else happens with the graph. And we won't go there yet. So the discontinuity happens at 0. So we could do this graphing. Now we saw if we filled in that hole, y would have to be equal to 5. Well, we can also do that without having to look at the graph. If I pretend that x cancels out, and I'm just left with the x equals 5, what happens if I find f of 0? In other words, y is f of x, right? What's 0 plus 5? Well, I see that it's equal to 5. So I don't have to know the graph. I don't have to be looking at the graph to fill it out and fill in the hole. So that tells me the discontinuity happens at 0, 5. And the zeros now, well, since we got rid of that, I know the denominator, I know the numerator originally was x squared plus 5x. And you think back to that fundamental theorem of algebra that says, well, if it's a second degree equation, it's supposed to have two zeros. Well, one of the zeros isn't actually a 0 because it cancels out. So then all we got to do is worry about what's left. And then we ask ourselves, where does y equal to 0? Because that's where it crosses the x-axis, right? So if I subtract 5 from both sides, do you see I get x equals -5? So the zeros happen when x equals -5. And the discontinuity is happening when x equals 0, y should be 5. Okay? So here's another rational function. I've got the graph off here to the right, but I'm not going to show the graph yet because I want to look at this analytically. Well, I know, without looking at anything else, I know that there's going to be a discontinuity wherever that denominator is equal to 0. So x equals -1 if I subtract the 1 from both sides. So I know the discontinuity is happening at -1. So it must be, I mean, because all these questions seem to be the same, it must be the numerator factors, so that one of the factors is x plus 1. So let's go up and take a look at that. So let's see, I've got to factor this numerator. Let's go to black ink. I know there's going to be an x plus 1. And then what multiplies to give me x squared? Well, x times x, right? And then what multiplies to give me -5 that will add to give me -4. And of course, I already know I've got a 1 here. So if I make this be -5, that's going to tell me when I FOIL it back out, I get x squared minus 5x plus 1x is minus 4x minus 5. So that's how that factors. And then I can see in the denominator, I've got the x plus 1. So what cancels off is that x plus 1. Now remember, we're only pretending we're canceling off. We're not really getting rid of it. But so what we should be seeing is this line, y equals x minus 5. But there's going to be a hole in the graph at x equals -1, because we know that's where the discontinuity is. So the discontinuity, I mean, how do we fill that hole then? Well, if we do -1 minus 5, that's going to tell me the y would be -6. So discontinuity happens at -1, -6. That would fill the hole in the graph. And then all we have left is, where does it equal 0? Where does this function equal 0? Well, what's left is just the x minus 5. And where does that equal 0? Well, that equals 0 at x equals 5. So the x-intercept is 5, 0, or it crosses at x equals 5. Let's go see how I did by looking at the graph. So here's the graph. I see there's a hole at x equals -1. I also see that it crosses the x-axis at 5. So, and you see how that, if that hole was the point -1, -6, that would fill in the hole, and that's where the discontinuity happens. Okay, so it's that easy without even having to look at the graph. Okay, let's go look at something that's just maybe slightly different. Okay, so what do you think? I do know that if you want, once you stop the video and try to think about where this is happening, where the discontinuity happens, where's the hole going to be, how do we fill it, and then what's left and what gives us the 0. So if you didn't stop the video, that's okay. Let's do it. So I know that the discontinuity happens wherever the denominator equals 0. So that'll be x at x equals 1. So I know that the numerator will factor to something x minus 1 times something. So what times x is 2x squared? Well, I think that's 2x. And then we could ask, what are the factors of -3? Well, there's -1 and 3. There's -3 and 1. I don't think there's any other options. So whatever we put here is going to get multiplied by x, and that -1's getting multiplied by 2. So I think if I put a +3 here, I think that's my only other option. If I've already used -1, it couldn't be -3, because that would make that be a +3, -1 times -3, right? So we know it's going to factor to 2x plus 3. So if we clean that up, here, why don't I just come over here and rewrite everything? So it's going to be x minus 1 times 2x plus 3 all over x minus 1. Then we make that promise that, right, we're going to make that promise that we're going to cross out the x minus 1, but it's not really gone. We just momentarily know that's where the hole is, and that's where the discontinuity is. So I'm going to be looking at the equation y equals 2x plus 3. So the discontinuity is going to happen when x equals 1. So let me come back to a pen. Y of 1 equals 2 times 1 plus 3, so that'll be 5. So the discontinuities happen at 1,5. 1,5, Dan. Well, 115. Let's see, what am I doing here? And then where is it equal to 0? Well, we're going to ask ourselves, where does here, let me stop this for a minute. Where does 2x plus 3 equal 0? Well, we'll subtract 3 and divide by 2. So at negative 3/2 or at negative 1.5. So that's where the graph crosses the x-axis. So let's go check out the graph here. Well, let's see. I see there is a hole at when x equals 1, it's undefined, and I see when x equals 5, it fills in the hole, so that's where the discontinuity happens. And I also see if that's negative 1 and that's negative 2, that's probably negative 1.5. I should have probably grabbed that point, but I could certainly convince myself that that's negative 1.5. Okay, so that's the things you want to think about when you're dealing with rational functions. It goes, we'll do more than this. I don't remember if we do this in this course. You will in pre-calc, okay? Give me a yell if you need any more help with this.